Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and I am back with a new tutorial. Presently we are studying marine auxiliary systems. The topic for today's lecture is the purpose of pipes and fittings used in ship piping systems. We will first learn about the purpose of piping system on ships and the fitting used in them. Next, we will study the classification of pipes and the methods of their standardization. Then we will explore the types of flanges used to join pipe sections. After that, we will discuss the fittings used to change the direction of flow or to distribute it to other sections. Finally, we will examine the method used to join pipes and tube sections together. Let us now go through each of these topics one by one in the following slides. Purpose of pipes and fittings used on ships. For transportation of fluids. For the operation of ship, several types of fluids such as fuel oil, lubricating oil, cooling water, compressed air, fresh water, sea water, feed water, steam and condensate, hydraulic oil, sewage, sludge, exhaust gases, and liquid cargo are required to be transported to and from various machinery. Types of common pipe fittings. Pipes are used for transporting these fluids and may be of various types and made from different materials, suitable for specific uses. To lay up the pipes, following pipe fittings are commonly used. Flanges. Flanges are used to join pipe sections of different types and may be of the various types. Elbows, tees and reducers. Fittings such as elbows, tees and reducers are required for changing the direction of flow, connecting different pipe sections and accommodating different types and sizes of pipes. Types and fittings used in ship piping systems. Various types of fittings are used in ship piping system to ensure system reliability, safety and maintenance. Valves. Valves are used in the piping system to control the flow, direction and pressure of fluids. Filters and strainers. Fluid flowing through the pipes may pass through various types of filters and strainers to trap dirt and ensure fluid cleanliness, which prevents damage or wear to machinery and increases its service life. They improve the safety and reliability of the piping system by ensuring unobstructed flow, reducing pressure drop, and enhancing performance. They are easy to inspect and clean, making routine maintenance simpler. Pipe expansion arrangements. Expansion joints are used in ship's piping systems to provide expansion and contraction allowance to piping used for transportation of hot fluids such as steam and exhaust gases. Steam traps. Steam traps are special types of valves used at the outlet of steam heating systems. to ensure that the latent heat in steam is fully utilized and that only the condensate leaves the heater. When a ship is constructed, a pipeline layout is prepared showing the interconnection of different equipment through pipelines. The layout plan indicates the size of each line, the material specifications, and other important details. All walls and fittings used in the system are also shown, along with their identification numbers assigned to them. These drawings are thoroughly checked before being submitted for approval by the classification surveyor. Once approved, the drawings are stamped and copies are provided on board for reference by the ship's personnel. Pipe sizes and specifications. Statutory bodies for governing pipe sizes and specifications. Pipe sizes and specifications for use on ships are governed by classification societies such as American Bureau of Shipping, Det Norske Veritas, Lloyd Register, and Bureau Veritas, etc., as well as International Maritime Organization and International Organization for Standardization and American Society of Mechanical Engineers. Factors on which these specifications depend. These specifications vary depending on types of system, the fluid type, operating pressure, temperature, and the location on board the ship. Common materials used for pipes on ships include carbon steel, stainless steel, and copper or nickel alloys. Pipes are typically supplied in standard length of 6 meters. Pressure rating of pipes. On the basis of pressure ratings, pipes are classified into the following three categories. Low pressure piping are used for bilge, ballast, freshwater, service air, etc., with a working pressure up to 10 bar. These are fabricated from Schedule 40 pipes. Medium pressure piping are used for fuel oil transfer, medium pressure steam, starting air, etc., with a working pressure from 10 to 30 bar. These are fabricated from Schedule 80 pipes. High pressure piping are used for hydraulic systems, high pressure steam, fuel injection, etc., with a working pressure above 30 bar. These are typically fabricated from Schedule 160 pipes or other heavy duty specifications suitable for high pressure service. Pipe schedule. Pipe schedule is a standard method used to define the wall thickness of pipes. It is a dimensionless number based on ratio of nominal pipe size to the wall thickness. The schedule number is important because it determines the pipe's pressure carrying capacity. The schedule number is calculated using the formula. Schedule is equal to 1000 into P divided by S, where P is design pressure in PSI and S is the allowable stress of material in PSI. Common pipe specifications. Pipe come in range of diameters and thicknesses to meet different design and operational needs. They are typically specified by NPS, that is nominal pipe size or nominal diameter. Based on the size, Pipes can be classified as small bore with nominal diameter 6 to 40 mm, medium bore with nominal diameter 50 to 150 mm, and large bore with nominal diameter 200 millimeter and above. Pipes are usually specified in terms of outside diameter and wall thickness. Standardizing the outer diameter also standardizes pipe fitting sizes, making their selection easier. Wall thickness depends on the pressure rating, which in turn is determined by the scheduled number of the pipe. For marine applications, Schedule 40 is most commonly used, except where high pressure or temperature is involved, such as in hydraulic or steam systems, where Schedule 80 or Schedule 160 is preferred. This table clarifies difference in pipe size due to change in their schedules. Pipe size under comparison is 50 millimeter nominal bore or 2 inch. Outside diameter is same in all the cases which standardizes sizes of fitting such as flanges, elbows, teeth, reducers, etc. Inside diameter of the pipe reduces as the schedule increases. As higher schedule can withstand high pressure, pipe wall thickness increases as the schedule increases. A 50 millimeter nominal bore pipe with schedule 40, schedule 80 and schedule 160 can withstand pressure of approximately 70 bar, 99 bar and 150 bar respectively. Common type of flanges used in marine pipes. In marine piping system, flanges are essential for connecting pipes, valves, pumps, and other equipment. They provide a reliable, leak-proof, and removable joint suitable for high pressure, high temperature, and corrosive environments. The sketch shows the common types of flanges used in marine piping systems. Lap joint flange. It is used in conjunction with a lap joint stub end. The flange is slipped over the pipe stub end but is not attached, allowing it to rotate freely. This type is used in systems that require frequent assembly and disassembly, or where precise alignment is crucial, such as in cargo and deck crane applications. It is cost effective for expensive alloy pipes and facilitates easier alignment. Socket weld flange. This flange has a socket into which the pipe is inserted and then fillet welded from the outside. It is used for small diameter, high pressure lines such as hydraulic or lubricating oil systems and provides a strong, reliable joint. Blind flange. A blind flange does not have an opening. It is used to close the end of the pipeline. Blind flanges are fitted on ship's bunker lines for receiving fuel oil, lubricating oil, and fresh water. Similarly, they are fitted on cargo manifold on tankers and can be easily removed to connect shore pipelines. Weld neck flanges. It has a long tapered hub that is butt welded to the pipe and is used for high pressure and high temperature systems such as steam and fluid lines. It provides excellent stress distribution and high structural integrity. Slip-on flange. It slips over the pipe and is fillet welded on both sides. It is most commonly used for low to medium pressure systems such as cooling water and ballast lines. It is easy to align and install and is cheaper than the weld neck flange. Threaded flange. This flange has internal threads allowing it to be attached without welding and is used in special applications. Common pipe fittings. This sketch shows commonly used fittings in ships' piping systems. Elbow. An elbow is used to change the direction of pipe, especially in confined spaces such as engine room. Common angles are 45 degree or 90 degree, with either a short or long radius to reduce stress caused by abrupt changes in direction. T. A T is used to divert flow to different systems or to combine the return flow from multiple branches into the main line. A T may be an equal T with all ends of the same size or a reducing T where one or two outlets are smaller diameter. Reducer. A reducer is used to change the pipe diameter from larger to smaller or vice versa in order to manage flow velocity and pressure. It provides a smooth transition from a main pipe to a branch pipe. Concentric reducers are commonly used on ships and are tapered systematically as shown in the sketch. Methods of joining pipes and tubes. Marine pipes are joined together with flange connections. Flanges are suitable for a wide range of pipe sizes and pressure ratings. They allow easy disassembly and maintenance of the system even in compact environment of engine room. Proper gasket selection is crucial to ensure a leak-proof seal. The sketch shows a flange connection which uses flanges at the end of pipes. The two flanges are then bolted together with a fiber gasket between them. For high pressure piping, metal flex gasket is used which prevents rupture of the gasket due to metallic backing rings provided on either end of the sealing ring. This gasket has corrugated metallic core, usually of stainless steel, wound spirally, and soft packing such as graphite, PTFE, or fiber sandwiched between them. This sketch shows a compression coupling which is used for joining small diameter copper or stainless steel tubes. The exploded view of compression coupling shows a technique for joining two tubes. A male union with outside threads on both sides is used to join the tube on each side. A conical ferrule made up of softer material of copper or soft iron is put on the tube end, which is then inserted in the union. When the nut is tightened on the union thread, ferrule gets compressed on the tube and the taper on the ferrule makes a leak-proof joint. This completes our study about the purpose of pipes and fittings used in piping systems, common fittings used in piping, and method of joining pipes and tubes used on ships. This book has been written by me and covers all the topics as per the Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in examinations conducted by Indian Maritime University. I am sure that the book will help students prepare effectively for exams and also support them in working safely with marine auxiliary systems. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found this tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.